made a what I'll call a junior programmer mistake, which is just assuming it would work. And that's the intent of our guest BYOD Wi-Fi network, but apparently Gerardo was saying he can just get to it on his phone. So the two things I can think of that we can do right off for folks that want to get into the hands-on portion is either for the Capital One folks, possibly we can do side-by-side pair programming, or try to figure out doing on hotspot from your phone. But I will be projecting up the same thing that you guys will be doing. And there'll be links. I sent out a link to the GitHub repo with the notes of what I'll be doing. And I'll update the meetup also with my slides as well. So anything that you missed out on or you feel like was too rushed, along with the links to a lot of other resources will be available. So let's see, a Java developer in Wonderland. I thought a lot about what to call this and kind of how to encapsulate what we're talking about. Well, first off, who am I? I'm Brent Vukmer, developer on the API framework. We're hosting this at Capital One. Thank you, Capital One, for doing that. Capital One's my employer, but these are my personal opinions and observations. So don't blame them that I picked this weird niche and this obscure programming language. So actually, before I dive into why is it a Wonderland, what's wonderful or weird or confusing or delightful about it, who here has done functional programming at all? It's actually more than I expected. And feel free if you want to shout out like the context. Was it a school? Was it a job? And what languages? Like Scala, maybe. Scheme, awesome. Haskell, even arguably more awesome. Scheme and Haskell are kind of like the two canonical options. And was that in school? Most people, when I talk to them, if they've had experience, they took like a functional programming course or a programming language course. The only exposure I ever had to it, I took an AI course, and so they used Lisp and a little bit of Prolog. But I didn't. I was just trying to get my assignments done. So let's talk about why I learned functional programming, and then I'll get into sort of the agony and the ecstasy, what's wonderful about it, what's kind of a struggle, and really talk about the learning experience. So it's a set of powerful ideas. It comes out of academic circles. It's reputed or supposed to produce clean code. There's a growing use in the industry, at least, if you gauge by the barrier, which I think can be misleading, but there's definitely interest, and it is kind of becoming mainstream, at least aspects of it. And then I started thinking about like our industry direction and where hardware is headed and where system design is headed, and kind of culminating in the serverless architecture that's kind of the new buzzword. And AWS actually calls theirs AWS Lambda. And there's clearly influence from the functional programming realm, which more or less to me just boils down to a little block of code, a pure function. Inputs come in and predictable outputs come out. And so you spin up this function, you run the code, and it's super, super predictable. And programming is all about defining and then composing these functions. So I already kind of led into it. What is functional programming? I have a link in the title here to Haskell. Actually has a great wiki, and there's a nice one-pager that kind of very succinctly and densely talks through the key features. But I thought I would try to reword it more from a software engineering perspective. So the most basic thing is you're dealing with functions, and these are first-class functions. They're not objects, they're not procedures. And what makes them first class is they're kind of intelligent functions. They can take other functions as inputs. They can manipulate those and transform those functions. They can return those functions after transforming them or create new ones. But they're sort of power tool functions. They're not sort of like just regular old little procedural blocks of code. You take those functions and you make small composable building blocks, kind of along the lines of the Unix philosophy of small tools loosely coupled. You have really explicit inputs and outputs. One of the things they hammer on is you shouldn't have any surprises about state. There shouldn't be magic happening with state in the middle of this little chunk of code that's executing. You should be totally explicit about what comes in and totally explicit about what goes out, and there's all sorts of benefits that flow from that. And along with that, you're carefully controlling side effects. So programming is not very interesting if you never cause any side effects. But you don't want to cause side effects unintentionally. that seems to be a large part of my day job anyway. So what you want to do is push out those side effects to the edge of your system. You're dealing with a file system, you're dealing with the network, you're talking to a database, but the vast majority of your code you want to isolate. You want to turn it in a functional programming role into this sort of chain pipeline of functions. And that pipeline is declarative, it's not imperative. It's really, and we'll walk through some simple examples in the hands-on portion of this. But when you look at it, it looks more like math. If you're saying, this is what I would like to happen to this list, it's not saying, here's how I want you to go to the memory address for this part of the list, and this part of the list, and this part of the list, and then I want you to copy to this memory address. And you might think, well, we're in Java, we don't deal with that nastiness anymore. But under the covers, it's still really modeled on the computer hardware. This is not. This is modeling computation. It's modeling ideas. So what feels weird about it, and this gets to the struggle, like I think a lot of people, especially folks that hear about it and haven't taken a course, are like, that really sounds intriguing, nice, there's a buzz about it. These, cool startups in San Francisco are using languages like Elm and Elixir. I want to be on that train. And then you get some exposure to it, and you're like, oh, wait, I'm at the wrong party. This feels really, I'm going to see you guys later. So I tried to just distill down for me personally, what are those gut level things that feel weird? To me, it comes down to muscle memory. Coming from a lot of time spent doing Java or C++ in a sort of Java-like fashion, you get used to a certain set of habits and ways of thinking. So here's a couple things that stood out to me if I really thought about it. Always be evaluating. Whether it's the language itself is always evaluating expressions, or whether it's you as a programmer, you're sort of mentally evaluating this set of expressions. And look, I tried to pick some sample code that wasn't, a huge production application or a huge open source library with tons and tons of functions. And you can see I deliberately picked something a lot more approachable. And we'll hopefully get to that right at the end of just a quick look at some of this. But even mentally, you're not the compiler, but you are sort of in your head, like, what does this reduce to? And it feels strange. It feels like a strain. Part of that, I think, is I'm just mentally used to assignment statements. They're kind of a break. Do this amount of work, assign a value, and take that value and do something else with it. And functional programming is much more about I evaluate an expression, and sometimes you sort of temporarily let the data rest, but you're usually handing off the result and doing yet another function. And that leads quickly to this rabbit hole, not in the bad sense. You can create this great structured code, but a rabbit hole in the sense of your mental effort to say, I've got a function, calling a function, injecting another function, create a function, and your brain just starts to feel fatigued. It's just, I want to emphasize here, it's not the intrinsic difficulty. When I came to Capital One of the folks in the audience was my team lead and patiently walking me through Spring AOP, and I just heard, I don't know how long it was, probably subjective years for him, but I was like, what the hell is going on? There's other arenas much closer to home for folks that have done Java programming. There's a lot of magic happening. And somebody new to that realm is like, what? How, literally, how do I find where to go next in the code? And just sort of feeling like you're overwhelmed with these unfamiliar constructs or ways of building systems. Oh, and I'll say the last one, code is data. That should be a lot more familiar now with the rise of rich front-end applications, JSON and JavaScript. Folks are more used to that, at least with data structures, but Lisp takes it, and Clojure as a Lisp, takes it to a whole another level. So that's not necessarily functional programming per se, but any Lisp. They really want the ability to serialize an output or read an input, and you go back and forth, and this is another thing that gets, I'm thinking specifically of macros, which is an area I deliberately haven't dove into yet. There's this whole realm of, I've got code operating on the code as it's getting compiled and expanding out to this whole other form. So these four things are sort of what I kind of hang my hat on. What feels weird about this? What kind of creates this friction that makes me feel like I'm not, at the speed that I want to be compared to my day job? Richmond, Virginia area developer, Vish, who I met at a DevOps meetup, had this great quote on Twitter a couple days ago. I thought this is too perfect. And just to sum up what I've said, I don't think it's learning the new skills or the concepts, even though there are some very deep, challenging, mathematical and formal, logical ideas under all this. There's some challenge there, but it's not that. It's primarily unlearning these habits, these mental habits. So here we are. We're in functional programming wonderland, and I thought this picture of Alice was pretty good. Like, she's conked out, and a couple of really random characters. And I think it captures like, oh, this is wonderful. This is interesting. I'm starting to get kind of fatigued. When am I going to get out of here? What am I? There seems to be a strange internal logic that I don't quite follow. But at the end of the day, when people use the phrase wonderland, they mean something wonderful. They don't, it's not primarily sort of the weirdness of Lewis Carroll's universe. And I hope what you'll leave that I want to leave you all with a balanced picture. This is really interesting. And it may, in the end of the day, be too weird for you, or just too different, or just not to your taste. But is it worth making a trip through this potentially as a learning and stretching and growing exercise? Just put yourself through some amount of pain, even if it's just this talk. Get hands-on with it for a little bit and let it stretch your mind. And I picked super simple examples deliberately. I didn't want to get hung up in that sort of nested function inside a function inside a function. But if you look at the examples and you think about them and you follow up on the resources I've provided, you'll get to go down the rabbit hole sort of as far as you want. So I chose Clojure, great community. That was really what drove it primarily. Part of the learning exercise, I think it's good periodically to get outside of your community, find another one that seems to be thriving and growing, and try to figure out why. What is it? Is it the technology as itself? Is it the benevolent dictator? Is it the folks that are contributing libraries? So great community, and relatively small community. It's not huge like Java at all. Good tools, lots of good learning resources out there, and more books especially. And I thought, if I play with this, I'll at least feel like I'm gaining this expressive power. It may not be something I get to do in a day job or want to do in a day job, but I'll get to kind of hopefully catch that feeling of what is it. Let me get past these barriers and feel like, oh, this is the superpower that's using the functional language. But I can sort of stay in my warm bath of IntelliJ, which I love so much. I just love IntelliJ. And I get to keep Java libraries. All your favorite Java libraries are really easy to interop with. And you get to keep JVM performance. So there are other options. I've got a list of them here. These are just the ones that have struck me. And you can kind of go two ways. Dynamic type, which is, Elixir is sort of a strange mix, but Elixir's got elements of both. Rapid is more like Clojure, and that comes out of the scheme academic world. Haskell is kind of the granddaddy of like the really rich type feedback. Honestly, I felt like I kind of needed to be a grad student to take advantage of that. It's like improving a theorem in order to get your code to compile. But it is a valid path, and it's kind of the canonical other example. So I think, and there are folks using it in the industry, and typically those people are super, super wicked smart. So don't discount that. And then Elm is this kind of interesting, really fast-growing thing that compiles a JavaScript, but is based on Haskell. But the guy that created this guy, Evan, is obsessed with a great developer user experience. I don't think I've ever encountered anything quite like it. And he has this great blog post about great error messages from the compiler for developers, but treating it like a user experience exercise. So you have this really powerful, fast compiler that's essentially doing proofs, and it can produce some kind of torturous, complex messages that he has done blood, sweat, and tears to turn into something that's really friendly and useful. And so I just want to say there are other options that are current, that are maybe based on decades-old work, but are currently being used. I picked Clojure, though, and I'm just going to kind of take it as it comes. So quickly, the features. I liked it that it was a clean focus on functional programming. One reason I would recommend it is, unlike Scala and Kotlin and some of the other things where you could still be in your IDE and it's still sort of you're within a reach of the Java world, if you're still in the JVM, is you're not mixing OO and functional programming. It's just straight up. They borrow a few ideas from OO, but it's pretty much straight up, here you are, functions is your life now. But it's pragmatic. Rich Hickey and these other guys are industry guys, they're not academics. And that's the other thing. I felt like it was a community driven by people with industry experience. Again, I didn't have to become a grad student. There's some useful abstractions, and then the hands-on will just quickly see their data types and just sort of what it's like to interact with those. It's not like in my class, AI class, where everything's lists or listed lists, and everything is list operations. This on the JVM. They've got some really good tools and patterns coming out from the technology stack of the language, but out to the community itself and the sort of practices and habits and tools that they produce, the libraries that they produce, some of the techniques that they're pioneering or extending. Some really, really cool stuff in the larger ecosystem. So, and yes, like I listed a bunch, and there's so many others. There's other great communities too. I have a list with just links of, if you wanted to follow up, some great talks, some great GitHub repos, some great blog posts. So this is just, and this is only a subset, but just wanted to list some of the people. Maria Neese, I got to hear at a conference. She's a neat example. She's a grad student who got into the Summer of Code and is now a core contributor to the JavaScript variant of Clojure. And that's, I won't have time to get to it, but one of the other really exciting things, and about half the people on this list are people involved in Clojure script. So you have Clojure, which is hosted on the JVM. Clojure script sort of piggybacks on that, but David Nolan is sort of heading that up, and it's very, very, very closely related. And almost all code written in Clojure can run Clojure script, but they are driving crazy cool stuff in the JavaScript world. So great community. It is a modern list. I had to put up John McCarthy, so you got the glasses and the beard, the inventor of the list. I'm straight up, it is a list. I mean, and if you've had an experience of a list that you didn't like, this is a list. But it gives you that nice code is equal to data, back and forth, back and forth. And this is something I wanted to dive into. It introduces helpful data literals, so you don't have just lists, you have vector sets and maps. And it has some nice abstractions around streaming and functions. Let's see. Yep. Okay, so introduction to Clojure, and this is just my bullets to summarize, sort of like if I had to sum up Clojure in 3 bullets. They're very, very data-oriented, and you'll hear that over and over again when you hear people talk about their libraries or their applications building Clojure. They're very concerned with managing time and state, so their interpretation of functional programming has a lot to do with that. And they've got both immutable data structures and then, which is fundamental to the language, you've got also some constructs for concurrency, some of which are libraries, some of which are built in. And you know, that's interesting. I'm not sure it's fundamental so much as their attitude about time and state is fundamental. And then it's very REPL-oriented. And so we'll talk about what that means. And this is the part where guest BYOD might be biting us, and people may want to huddle around folks who have hotspots. So can we quickly pause and ask who has an internet connection and who has Lineage installed? Guest one? Guest BYOD? Yeah. On your laptop? Oh. Interesting. Yeah, Macs still have a little ways to go. Up and along some ways. Maybe I wasn't supposed to say that. Everything's great. All right, so you guys are good? And I wanted to pause too real quick and ask, I'm throwing around the term REPL. A lot of people have heard about it or run into it in college, but does that ring a bell? You know, people, if somebody said, what's the difference between a REPL and like an interactive console? Like, I've used Ruby, and Ruby has this, you know, Ruby shell or whatever. I've used Python or Ruby, and I can bring up this interactive. What's the difference between that and REPL? What's special about a REPL? But anything? I think, and this is not me as the expert, it's me as the learner, but I think to me the difference is, if the language is designed around using a REPL, it's a REPL. If it's fundamental, if it's a nice tool that somebody built on afterwards for limited interaction with most of the language, it's, you know, it's an interactive console, which is very helpful. But that's part of why Lisp has that kind of weird, super abstract, simple structure, is they wanted to be easy to parse. They from the beginning, they wanted to be building the language and extending the language via REPL. So I'm going to go ahead and jump into trying out the REPL. See if this works. So I also sent out links to this set of notes, and this is what we're going to run through. And then I'll kind of circle back. If we have time, I'll try to talk about this refactoring example. Otherwise, I've linked to the repo. But I wanted to just quickly do some hands-on stuff, and so you can start to see how you can almost play with the environment and start to learn it. So I'm going to jump over here, and I'm going to type line REPL. On Windows, I'm not sure if it's line or something else. And this, so LineEngine is wraps Maven. Like a lot of other things under the covers, you're not far from Java. But it's not just like Maven for running projects. It also gives you this ability to start up a REPL. So right now, here, we're not like, I'm not in a project. I'm not designing a namespace and functions, the equivalent of like a set of classes. We're just playing. We're just in a REPL kind of free form. So the first thing I thought we could do is just play with tab completion. So if you enter an asterisk and hit tab, you should see what just came up. And then you can look at, what's probably a little mystifying, a bunch of global variables. Clojure has namespaces to organize its code. So you can do this star, NS star, and it'll just tell you if you're switching between namespaces, or it's almost think of it as you've got a file with a bunch of functions, a file with another bunch of functions, and a namespace is just a way to keep those functions from colliding to the same name otherwise. So let's see. I'm going to keep going. Feel free to tell me to slow down or speed up. So, didn't do any of the stuff? Sweet, this is for star and a star. Yeah. Here? Is that what you did? Or are you doing something else? So that's just a whole bunch of global variables. Like what are the arguments? Yeah, so if you hit asterisk and hit tab, it should print that to the for you. Sweet. So when LineEngine starts up a REPL, it prints out your Clojure version and some other helpful stuff, and it has just some quick hits of things you can try. So I thought we'd just try a couple of those really quick. So find doc is one, you just give it a string like, hey, TDD is cool. I think later I'm going to use a unit test. So find doc unit test. And it turns out there's a whole bunch of text about how to do unit tests built into Clojure. And then if you scroll up, so when you get documentation, it's got this dash, 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 and start it out. And it says Clojure tests is the name of the library, which is usually the name of the namespace. So let's paste that in there and tab complete. So Clojure.test/tab complete. And what I really want to know is how to run stuff. Sweet. So, and we can see what happens. And we're not in a project, so it's probably not going to, it's just a function. Sweet. So under the covers, we've got, when it says object, I mean, under the covers, this is implemented in Java. Clojure, something to point out is it doesn't have its own like separate toolchain. It's just a library. Clojure is a jar. So under the covers, this is all implemented in Java. You've got a whole mess of classes that have been generated with a whole bunch of static functions and just a way to do indirection between those classes that get created. So what I did was accidentally say, give me the object that refers to instead of run it. So let me do this again. So I was just trying to show you like, hey, I'm in this environment. It's supposed to be dynamic. Let me try to find something that I can run that I'm interested in. I'm interested in running tests. Well, of course, I don't have a project, so running tests is not going to get me very far. But it is built. You don't have to get into a project. You don't have to pick an IDE. Part of the other thing with a functional programming environment, and really, I think any truly new technology is if you have the I don't know whether I should say OCD or ADD issues that I have, but you can get way down with the decision tree of which one do I pick, and then you get bogged down in tool issues like, oh, the setup isn't working right. I started you guys out with Lineagen because it's just a nice, simple tool that most people in the community use. You just dive in and just play with it. And there's low investment, so you're like, well, I can kind of play with this for a while and not feel frustrated that I've sunk all this time learning the tool chain or picking a tool chain. All right, so let's get into actual like functional code, all using built-in stuff. So I'm just going to run through some examples. So here's a kind of a famous example for new system. Just add 3 and 4 and prints out the result of the expression. You can do, there's a lot of built-in functions. You can do more interesting things, create a range of numbers. And I was trying to show you earlier, like the notion of navigating around. 2 other things that the REPL says when you start up is, hey, there's a doc function. So somehow you figure out, like I'm on some website somewhere, I figure out where I've searched kind of dynamically around and I found this range function. But I'm not really sure what it does. Show me the docs. And you can also get the source for it. So the docs, I will say, are really terse. The docs that are built in, they are technical specs. It's not a tutorial. So there are some great books and there are courses that you can pay for, and there's all these resources. That's not what this is. This is more like this is terse little spec for what the function is. You can also look up the source code, and that's something else I think that's interesting about this. By convention, most Clojure libraries include the source. They're intended to be used like this. Most of them have these doc strings in their functions, and they include the source. So most libraries, you may be locked into this. Most libraries are meant for this kind of exploration and bundle this stuff just kind of from the get-go. So what was I doing? All right, okay, so a simple example of composing functions, just using built-in stuff is, and this would be a lot more whizzy and sweet and IDE, but again, let's just kind of do it from the ground up. So there's a count function. We'll just take any collection, take a map or a list or a set and tell you how big it is. So I have one expression that creates the dynamic list, and then I have another expression that takes the result of the first one. It says I'm going to take that value, that expression is turned into a value, and I'm going to feed it into this next function, and the output in turn is another number. So again, super simple, but at the end of the day, that's really what all this is. It's supposed to reduce down to these nice, concise functions. I think I have a note here just to say, I don't know if I said it earlier, like if it freaks you out after all seeing parentheses, just mentally try to move the function name outside the parentheses. I find that helps. We looked at the source for range. Oh, and so one other thing to point out is, along with this notion of exploration, is you may not find everything in the tool. It says it returns a lazy seek. It doesn't tell you what lazy or seek means. The seek happens to be the abstraction they've wrapped all their built-in data structures with. So you can say count, and it doesn't say, well, how do you count a map? How do you count a vector? Where do I start in the data structure? I mean, that's a super simple example, but it has this seek abstraction. But what's nice, though, is you do have a starting point to kind of keep learning. You're like, well, okay, now I got to go figure out what a seek is or what lazy is. And there's the Clojure website and the Clojure docs website, and they have usually more expansive documentation, more examples, tutorials, etc. But I like it. They just build into your first exposure to the tool. You have a lot to go on to sort of get you learning. So let's quickly just go learn some actual Clojure. And I'm just going to run through the basic data types. So I created a list. There's a shorthand for that. And I can do the same kind of business here. Not super exciting. So what else can we do? So we can do, this is kind of classic list operations. You say, give me the first thing on the list. Will give me the rest of the things on the list. There's another like little touch where they've updated old school list with car or cedar, which nobody that was not alive in 1958 understands what that means, but they said like first and rest seems a lot more approachable maybe. Let's see. Okay, so I think I told you guys, I recommend typing in the REPL 2 as opposed to pasting in code examples. I'm just going to freely violate my own advice. So you can add stuff to lists. And then let's play a little bit with immutable data. So I'm going to do a def. So I'm at like this top level, I'm going to actually declare something. So we do have a little piece of state here. So here's a list of things 1 through 6. And then I'm going to say, take that list and append something to it. And then if I just type in list 1, it's going to print what's in it. Just to show you guys that these fundamental operations, like you're not going to find a fundamental operation on collections of streams that lets you get in there and start ganking around and changing the state. If you get a collection and you pass it into a function, it's going to return a copy with whatever you specify. And that can get really, really involved. And they've done very clever things behind the scenes to optimize so that is relatively performant. So what else? Vectors. So they have a little, I'll go through kind of the same example. So a vector just lets you index into collections if you manage to copy paste your code correctly. So you can do first and rest. Because it's a vector, it puts things on the end of the list instead of the add, use conj operation, puts it on the end. But you can also say, put something at a specific index in the operation, a specific index in the vector. And then we have lists, and I'm not going to copy all of this in, we have maps. Maps and sets are the two remaining. And this is where things start to get interesting because this is where you have like a little bit of a blend of OO. So the :A, that's a keyword. Maps and keywords kind of know how to interact with each other. So in this expression, I've got a keyword. And the example I didn't paste in, you can have a function where it says, get from this map this key. But here we're just saying, hey, I've got a keyword, here's a map, make something happen for me. And keywords, behind the scenes, there's this protocol abstraction that lets them say, I know how to do that kind of lookup. And then the reverse is true, that you can take a map, and I'll do it with strings instead of keywords. So a map is smart enough to do the same thing. You've got a data structure that can act like a function. And I don't know, you can put stuff in a map, you can take stuff out of a map. And this is all just the building blocks. Just the fundamental things that you're doing a lot of. Because when we hopefully take a quick look at the code, what they're doing is they're saying, I've got let's say a list of maps. My maps are essentially records. Am I aspirating my statements too much? But you've got like a list of maps, and the maps might be like invoices with a model. But you just straight up are like, I just care about keys and values. What's those records? And then I got a list of them. Maybe it's more complicated than that. But you're kind of like straight ahead with the data, and then you start figuring out, well, what are the things that are happening to that data that I'm interested in? So you end up with a lot of code. You'll refactor it so it's readable. You've got nicely named functions, but you're doing a lot of this, what ends up being relatively straightforward operations on data structures. Merge maps. I'm kind of putting myself to sleep, so go ahead. I'll do a set really quick. And these are all built-in functions. So yeah, in the set that contains the numbers 1 through 3 is 3 in it. Yep. What about 4? Nope. All right, something that's a little bit more interesting. I want to do set difference. I have no idea what the function for that is. Okay, so there's a function called difference. It sounds good. I'm going to try to find a difference between two functions. And again, I'm just like, I don't know Clojure. I'm just going to start learning it. That's not good. So what just happened? There's a compiler. This is being compiled to Java under the covers. The Clojure guys are, I talk about the Elm, like great user experience for developers. Clojure's been a little more stringent and feel like, we need to sort of get our chin up and deal with the fact that it's Java under the covers. usually you kind of get used to this. You're like, okay, unable to resolve symbol. I'm going to ignore the noise about whatever code it's generating. It can't resolve the symbol, so why can't it resolve the symbol, and why can't I control my screen? Well, if I go back and look at the documentation again, it tells me that Clojure set has got its own namespace, its own set of functions. So instead of saying just, what I said before was just call the function difference and give it these inputs. That's assuming that the namespace for that function is already loaded. And like the core Clojure namespace is loaded by default. They don't start totally, with nothing. But they don't, you have to specify after that. And if you need something from another namespace, you have to tell it what to use. So now it's happy. It's like, okay, the set difference is 1 and 2. And then I just call it out here, like, this is where the documentation is helpful. It doesn't give you a lot of examples. It's not going to tutor you. But I'm a little hazy because, I went to public school, how to set different difference work. I'm not really a professional software engineer. But this will tell me, this is exactly the spec for what Clojure does for set difference, which is the actual, mathematical, logical definition. And then I wanted to quickly go to Clojure docs and show you all. So here's, sort of generated from the documentation, but then here's community examples, which is really fun, and that very quickly turns into more advanced usage. So Clojure docs is a good resource when you want to sort of come up out of the REPL. You sort of said, okay, I did the little, chubby little baby legs intro, but I want to start doing more advanced stuff. Let me take some examples I can run right in the REPL, and typically they have like a quick little explanation of what's going on. What else do I have? Okay, so really quickly, I'll show transformations on collections. Again, I'm trying to keep it relatively simple. Let me clear things up. So this is saying create that list, the range 0 to 9, which is going to be 0 to 8 if I remember right. And it's just going to say, do a filter on that using this built-in function. I could construct a function if I wanted. So that looks like it makes sense. You can also not filter existing stuff, but you can do a transformation using map. And so this is a little line on the screen. This is more of like the built-in shortcut syntax. You could define a function. I did it the short way because it's just a little bit more noise, but arguably it's noise that way too. So colon parentheses is just a shorthand way of saying, here's a little anonymous function. The percentage sign says there's a one parameter coming in. And it's just saying, so it's a function that says multiply by 2 the parameter that comes in. And map is just going to, again, this is declarative. This is, like math or logic. It's just saying, you got a list or you got a collection, and I just want you to apply this transformation on it, and I don't know if you're going to run it in parallel. Actually, I do know they're not going to run it in parallel, but the intent is, under the covers, I don't know what optimizations you're running. Just do it. So that's the work. And then I wanted to just use this as a way to quickly define, no, I don't want to do that. Oh, yeah, sorry. Okay. iTerm did not like that. So I'm just taking this function that I've already done, and this is a ridiculously simple example, but this is what people do in REPL in more involved ways. They literally play with the code and they kind of build it up and they try stuff and see what works. They're kind of doing TDD, but it's almost like it's just direct. Like, does this work? Let me try different scenarios. When they find something they like, they define a function. And then they'll start playing with it, other functions, and composing together. And when they like that, they'll actually put it into their source code and check it in. So now we've got our map mult2, which is way overkill for what we're actually doing. But so I've captured this stuff that I personally find really gripping and compelling as a function, but not a function that will live forever. But I find it useful for this session. And so I get the exact same result. It's the exact same code. And this is, I blame myself, but it's not a super helpful name. This is not a super compelling example. But part of what I've noticed in the community is people almost have like a code golf tendency. They're like, let me have a function name with 2 characters, or let me have a function name that's like as compressed as possible. And the good examples, people are like, no, this is going to be read later by other people. Let's kind of pull out of that and have readable names. So the great thing about this is, I know these are childishly simple examples, but you basically just learn most of Clojure. Of course, there's a lot more. If you wanted to look at how it was implemented, how to make it performant, how to handle concurrency, and as part of pruning, I started with this presentation super overstuffed and leaning toward like, let's jump right into development. But then I kind of backed out of that and I said, you know what, you guys can go, if you're interested in this, you can go look at Core Async, which is a library for asynchronously connecting components through channels like Go does. You can look at the concurrency constructs. You can look at building web applications. I wanted to provide you with simple examples that might inspire you to go do your own little REPL session and just explore. Literally, like, I mean, be like a kid, just kind of wander around Clojure, wander around REPL, get on Clojure docs, maybe jump on some repos, but don't overwhelm yourself. And try to use these simple examples to kind of click over into that functional mindset. So the last thing, and let me click back to the presentation here. So we learned some Clojure, the data structures, working with functions, immutable data. I mentioned lazy sequences, but didn't really show you the awesomeness of having 100 million things on a list and dealing with them. But again, at some point, this will be future exploration. I wanted to talk a little bit about modeling before I wrap up. And I'll try to show you guys, at least you'll have seen it and you can go look at it later. So this guy named Eric Norman has a website. He offers online mentoring, a series of courses, and a discussion forum. I found it incredibly helpful to have that kind of interaction as opposed to this book, because this is so different in you. And a lot of his courses really deal with this thing of modeling. I've got some data, and it's specific to a domain, and I want to end up with a domain-specific language. Any of you, how many people have heard of domain-driven design? No, 1, 2, 3, 4. Okay. So this ends up in a place very similar, if not exactly like that. In fact, Gareth Evans on Twitter periodically mentions Clojure. I think the difference is his designs are not bound to OO by any means, but typically his example code and stuff like that starts out in the OO world. But he's very much about what is the data and the names. The data, the operations on the data, and the names that you give it, especially at the boundaries. How do we bound these contexts of what we're dealing with, and in a context like name it intelligently, and be able to deal with the data effectively. So I think Clojure in large part was inspired by people who were just really sick of enterprise Java, XML, and over-designed systems. And they're like, I just want to take this data and do some transformations on it, and I want an effective tool to get out of my way. Having said that, what they've produced is really compelling, but I will say that my impression is refactoring is absolutely key, where you end up in a black hole of just incredibly dense code. So I'm going to just quickly clone this solitaire project. If you want to follow along, feel free. Let's see. See if I can go into like early in the project. So he has these nice tags where he sets up. He kind of breaks up the lessons by git tag. So I wanted to just show you guys sort of early on in the lesson. So think about what this would be in Java. We're modeling cards, suites. He's modeling the game Solitaire, but he starts out just trying to like, well, how can we model this? But all of the options he talks about are these super simple data structures. There is nothing that looks like a class hierarchy or a proxy factory being or adapters. You don't need any of that. It looks really, really Spartan and simple. And then there's just some quick little utility functions about, the card is basically just a vector, and you've got the suit and the value. So you just need some tests for whether this card is in this suit. And some conversion functions. But it's all, this is like, it almost looks like pseudocode. And then he's got some sort of, this is just more like nodes of what he's playing with. And then he says, well, let's drive this with tests. So I'm going to just quickly check out. Let's jump ahead by 1 and see what it looks like. Not a lot. Jump ahead a couple more. Here we go. So now he said, all right, cool. I've got cards that are simple data structure. I've got a function. So he's got, if we come back to his card namespace, that looks pretty much the same. He's just starting, he's saying like, let me use a test to kind of grow my code. I'm gonna start growing the behavior. And if you take his course, he does a nice job of just sort of showing how he incrementally pulls stuff out of the test and transform it. And as he does so, he's trying to like, well, I could do this, I could do that. Let's kind of pause and talk about the options. But I think, let me just highlight here that this is what I mean about code density. He's got, okay, I'm in a test. I've defined a test. This let is just a way of defining variables. I've got a map, a set of maps, lists, and the individual things are kind of simple, but as your eyes look at this visual information, you're like, I'm starting to feel a little overloaded. And then you're like, well, this looks like a data structure. Okay, he's just defined. I get this. I the tests. These are like the test fixtures. But then he's like, okay, and one of the variables is move, and the move is a function. He's dynamically creating a function. Well, hold on a second. And then he says, okay, well, let's have another binding here, and I've got a count, and then I've got where I'm coming from and where I'm going to, and what the cards are. And then let me just define this kind of threaded set of functions. And this little thing right here is a threading macro. So it's trying to deal with list where you have a function inside a function inside a function inside of a function, and that it's a way Clojure has tried to help with that code density, so that the threading macro essentially turns that from this highly nested set of function evaluations into just a stack, and so you kind of see it from the inside out. The inside thing goes on the top, and then each successive one, and the threading macro threads the result through those functions. In any case, this is kind of where I started to say, maybe I've made a life choice I'm not comfortable with. What's going on? So I'll jump ahead. And again, he does it in a very stepwise fashion, so I'm not going to promise magic. But I just want to focus in on this. So that he's got the same test fixtures, which is all pretty clean, right? Like you read this and say, okay, I get it. He's making decks of cards and he's using the nomenclature, the tableau on the stock from the domain. But he's reduced this down. It's not actually even code anymore. This is all this right here. So this is a keyword, that colon, a number. This is a vector. Like this is the same stuff I showed you guys. It's a little more complicated because he's got a vector with vectors in it. And then if you go in here, he's now got this notion of applying a move where you introspect him as data and then dispatch, which is, nothing super fancy there. It's not, and like a lot of things, it's not that you can't do it in Java. What I like is the absolute minimum of ceremony here. And I'm not doing him justice by trying to rush through it like this, but it's really, this was the aha moment where I'm like, my head hurts so bad, I'm not sure I'm up for this abstraction. And then he made it all go away. And it's still there. If you come back to his core stuff, he's defined what is a move, what is a transfer, what is a flip. He's like this one right here. Here we're back to this threading macro. So he's refactored this code out. And we're still threading one function's result into another. He's defined a partial function here. There's some fancy stuff going on. He's isolated it. You can say, I am willing to defer the headache right now, but I know this is a move. I know how it works in a test. When I want to really understand how he implemented a move, I can puzzle over it, but he's allowed me to pull back up the tower of abstraction and I've tested it all out. I know it works. Or in my case, as a learner, I jump ahead to his solution, and I'm able to kind of work backwards because he's done a nice job of, this is not much code. It's nicely named. The variables are nicely named. He's even though it's a different paradigm, he's still using good team discipline. So let me switch back. That's all I wanted to show you guys as far as hands-on. So I'll sum up. The drinks, if they're not here, will be here by 7. So I've got like 5 minutes before the more exciting part of the evening starts. So summing up, the good, the bad, and the ugly. And this is more, I want to leave you with my thoughts. I'm a learner, I'm not an expert. So I've linked, if you look at some of these resources, to people who are professionals using Clojure day to day and have years of experience. And more sort of, I'm trying to give you a well-rounded picture, not just of the things I called out as sort of a newbie, things that are confusing as you come in, but there's also some things that people are reporting that are not struggling to learn it and apply it, but people are using it. So the good, I've already talked a lot. It's simple, it's expressive, it's powerful, awesome. The bad, you lack that type feedback. I don't think Java's got great type feedback. Not that I'm an expert on advanced types, but I've seen way too much of people using like strings for everything. So at least with Java, having types is not necessarily this magic. Tests help a lot, but tests are not everything. So it lacks type feedback, so as a result, you have to write a lot of tests. And because it's based on Java, when things kind of go pear-shaped, you have all this flexibility. So I don't know, somebody sent me a list of lists of maps of kind of this data that's structured in potentially a very complicated way. And I have these wonderful ways to destructure it and say, I kind of want to almost write this ad hoc query that drills into what I want. I'll do a transform, and then I'll pass that back out. Awesome. So succinct. I'm exploring the data. I'm set free. I am a power developer. But if there's something about that input that I didn't expect, Clojure by itself is not going to validate for that. And so there are reports of null pointer status. So that's part of the situation. The answer I've gotten from folks when I've asked about it is that it really is about TDD and other testing disciplines. It has not been an issue. I think it is an issue. I think maybe people have run into it with less disciplined teams. But even that is a little bit of an equivocation. I think it's just kind of fundamental. You've got a super dynamic language built on top of the JVM. When the dynamic language doesn't know what to do, if it's built on the JVM, you're probably going to see an alternate explosion. So the ugly, and not really ugly, I should say weird maybe. This gets back to like the Matt Hatter, the mouse, and whatever the other was. It just looks weird. The code can get very dense. So I tried to kind of curate over the past several months, kind of collecting these links and stuff I've been looking at, for, against, and just sort of what we run into. I like the guy that says he has a whole presentation about stuff he doesn't like about Twitter. He's like, you're going to love it anyway. Well, maybe. I hope everybody here checks it out. You might not. And some going into both types. Types of the weather is a great talk, recent talk. And then this new Clojure spec built into the next version of Clojure will have much more powerful abilities to do validation. But it's still not going to be a type system. So that's there if you want to look into it. I also tried to give you in one slide, either if you did the stuff with me in the REPL, or you're going to rush home and stay up and run through it. And you're like, what's next? I'm ready. Put me in the game, Chief. This is what I would say next. Use LineEngine. So I'm trying to walk down the decision tree and prevent you from being OCD, ADD like me. Don't get paralyzed by choice, and don't go pick something off a blog post. Listen to Mr. Vukmer and get LineEngine, install it if you don't have it, and then Cursive, which is a plugin, and I linked to it to IntelliJ. I didn't want to tell you guys tonight to try to download 600 megabytes over what may not be an available Wi-Fi link. But it is an awesome tool, and if you're used to Java, I think it's going to be much more familiar than trying to learn Emacs or relearn Emacs or Vim, or there's a host of other options. So do those two things, and then I do recommend there's this Eric Norman guy. He has a course. I think it's worth the money. I paid the $25 to take his course. There's plenty of other resources. But then the website, Clojure Docs, and the Clojure Cookbook is a book of recipes, like the cookbook pattern across all these different domains. And that's something I think, if you're like, well, I like this enough to try it out. I obviously rushed home and spent 4 hours on it, but I want to know if I should spend more time, maybe like the rest of my weekend. The Clojure Cookbook gives you an idea of the domains it's being used in. I wanted to link to building a web app. A lot of people are building a web app for some reason. It's some part of the job. Heroku has a really nice tutorial. Just it's more about using Heroku, but it'll get you with the Clojure web app. Luminous is a very beginner-friendly Clojure framework. Clojure people don't like frameworks. They like libraries. As a result, there's 4 or 5 really cool-sounding libraries that all do the same thing, but a little bit differently. And the Luminous guys like, just have pity, and can we we want to be professionals and have secure web apps, so can we just put this together? So really, he's curated a set of libraries. You can pull them out and do something different if you want, but he's kind of assembled that and will scaffold up a project for you. So a web app is an option. Clojure script is super awesome. If you wanted to do another sort of rainy day afternoon, I've linked to some quick demo, either GitHub repos for Clojure script itself and for some tools. The Figwheel one, the guy actually did a Flappy Bird demo. It is not refactored Java Clojure script code, so it's not gonna. He's like in there doing the demo. He's like, how do I do a sine wave so the Flappy Bird moves up and down? Let me play with it. But his point is not the end goal of like I'm refactoring it. He's showing you this interactive quality of here's a bunch of code I threw together. Well, what's cool about Clojure script is it's loaded. The Figwheel tool loads it. It hot loads it in the browser. And the dev cards is a accompanying tool that lets you sort of live load stuff, try stuff out in the browser. And a couple good articles. Data science, so just another domain you can try, something worth looking into. And then I just linked to some good books and articles. And with that, if anybody has questions in the next 30 seconds before there's a rush for the drinks, I'm happy to take and talk to whoever about whatever questions you have. Yeah.
Thanks for the presentation.
Awesome. Does it make me a newbie that I don't know which M word you're referring to? Oh, yeah. See, yeah. And I knew there'd be people here that were smarter than me. Yeah, I didn't mention the monad, and that's one of those functional constructs that Haskell is really big on. It's all about the idea of controlling side effects and having what they call pure code, pure functions. Clojure, you can do the equivalent, or I don't know if it has to be with agree. But at least they have some of the same intent, but they don't have the same kind of controls in their constructs that he's talking about. So like explicitly, here's a monad. There's gonna be side effects. The monad is here. We're gonna protect you. This is I/O. I'm announcing. This is an I/O operation. Yeah, I don't. It's not that Clojure folks aren't concerned about that, but they definitely have kind of relaxed those constraints a bit. But thanks for bringing it up, and that's another good reason to plug Haskell. I just, if I was going to do like one half-baked presentation, that was as much as I was going to do. So I wish I had the experience with Haskell to give you like a quarter-baked version of that, but worth looking at as an alternative. Anybody else? I know what we're all thinking is we stop talking so I can rush right past the beer and get it started on Clojure. Yes, sure. Yeah, and that's what I don't know how it came across when I was trying to toggle back and forth between the Git tags. And the fact that it's a toy project and that he was already sort of being very orderly probably wasn't the best example. I think it's a challenge. I think the other thing that you run into, this attracts, one of the reasons it's attractive, I say community. I feel like you kind of want to go where the really bright practitioners are, the people who really want to do awesome work. But it's a double-edged sword because a lot of times those really bright people are very independent and ornery. And some of them are bright and capable and daring and also really concerned about production concerns and maintenance. And some of them are just, on track and more, I think, more about the bleeding edge. And that's why I kind of referenced the startup side of it. So I think on the left-hand side, if you have that production orientation and follow TV, I think it's pretty good. I think if I were going to start up a team, I wouldn't sign myself up necessarily to be the team lead, I want somebody who's done TDD and these other property-based testing, some of these other unique functional practices to kind of get that started, make sure we got off the right foot. I think I would also want to latch on to some good libraries that are examples and kind of be like, this is our code should look like this. But I think you have, just like in OO, you have the danger of just the proliferation of, there's a project that a couple of us have worked on together, and it was really amazing when I went from 4 teams to 10 teams, and I lost at like 40, I think I passed out, but 50. But it was really amazing how much trust got into the code, and that was with rigorous attempts at discipline. So I feel like it's just kind of a problem. But I do think that with Clojure, with functional programming, it maybe just underscores it. Like, I don't think that you'll end up with garbage. I think you'll just end up with super dense code that, doesn't read nicely for somebody who wasn't on the team for 2 years. Well, that's really interesting. One of the reasons yeah, go ahead. So the question was, are patterns dying? Like, do you use design patterns? I don't think so. And so actually, one of the reasons I like this Eric Norman guy is like a lot of folks actually in Clojure, another thing I think is great about it is they've crossed that bridge. They may have spent 5, 10, 15, 20 years doing Java or other OO languages. So, and some of them are kind of cranky about, like, I'm done with OO. That's why I do this. But I think there's a lot of them that acknowledge, like, hey, there's some good stuff. So Eric Norman is one of them. And, like, for example, he wrote an article about the solid principles. And he's like, yep, straight up, this is great stuff, and here's actually why. I think what he said, though, is it's more kind of baked into the language. That some of this stuff is more like if you're just doing Clojure the way it wants you to do it, you're going to get some of these benefits. Whereas a more verbose language or whatever, the stuff that people throw at OO, you kind of have to make it a formal pattern. That was a lot of the design patterns guys came from C++, and that was definitely the case. You could do so many things, so many different ways in C++ that you kind of had to lay down patterns to get people to adopt, and then Java would kind of follow that pattern. So no, I don't think patterns, at least a lot of patterns, I think, are either baked in or people explicitly follow. But you'll definitely find some cranky people who are like, TDD, no. I'm a super sweet Clojure developer, and I just do it all in the REPL because I've got a 200 IQ. I mean, but most people are more responsible than that. And like, yeah, I do these other things, and I do TDD rigorously, and just fast feedback, and I have CI students. Thanks for asking. Anybody else? All right, well, thank you all for Jordan. Yeah. Yeah, because that's essentially searching inside the jars. Yeah, there is some stuff. There's some minor things, and can I just? I mean, this is a safe space. Can I just be even more nerdy for a minute? I think you guys want me to be even more nerdy. So the Clojure guys are just kind of nuts in a good way. And so another thing they've done, if you're on Mac, if you're on OS 10, is this thing called Plonk, which is command line Clojure. So one of the dings about this REPL is it starts up slowly. It's not per se that Java itself is slow, but Clojure is doing all this machinery to get geared up so we can do all this dynamic lookup. And for whatever reason, making that happen fast has not been a priority, has not been successful. But anyway, so Clojure scripts, when you start that up, when you start Plonk, I think it's running maybe on the JVM, but it's super fast. So people are literally doing like these, I don't know, batch jobs or whatever. They're doing this crazy command line stuff in Clojure scripts. So that's my next level of nerdiness. I'll stop there. Yeah, Clojure scripts, there's a lot of cool, another use of it that I've seen is people using it. I mentioned AWS Lambda, so people getting on AWS Lambda and defining these functions in Clojure script. And the idea that with AWS Lambda, you only have a certain amount of time to, warms up an instance and executes your code when it's done, and you might keep it around a little bit, but you don't necessarily want this, JVM startup time. So, yeah, of all the things I highlighted for you guys, if I could pick one for you to look at, it would be ClojureScript. And if you wanted to just, not ClojureScript per se, but as Gareth said, just doing these exercises, you don't have to use Line Engine necessarily. There are these websites like Clojure or something like that. But anyway. Well, thanks for your time. I really enjoyed getting to present to you all. It was useful and interesting.